Okay, so let us start with product component. The first is Node MCU ESP8266. This ESP8266 is the main microcontroller board that used in the project, which provide for the Wi-Fi connectivity and serve as the brain of the system, which controlling the sensor and communicating data to the web server. So secondly is the I2C LCD display. These are used to be provide for the user feedback in the project, and display offer a convenient way to show the real-time sensor data such as temperature, humidity, and gas concentration to make it accessible to the user. Continue with the DHT11 sensor. This sensor employed to be measure temperature and humidity level in the environment. It provides the accurate reading and essential for monitoring indoor conditions. And continue with MQ135 gas sensor. This sensor utilized to be detect and measure the concentration of various gases, particularly is carbon dioxide, CO2, and alcohol. It helps to assessing the air quality and identifying potential health risks associated with the high CO2 levels. Lastly, which is the breadboard. This breadboard serves as a platform for the prototyping and connecting to the sensor component with the Node MCU ESP8266. It facilitates easy communication and experimentation and allows for quick adjustment or modification during the development process. Alright, so let's continue to the project source code. Firstly, we must include for the library inclusion. The code includes with the necessary libraries for working with the Node MCU ESP8266, like for the LCD display, the DHT11 sensor, and also the MQ135 gas sensor. Next is the Wi-Fi configuration. Define the SSID and also the password for connecting the Node MCU to the Wi-Fi network. Continue to the onboard LED control. Define the pins LED onboard used to be control the onboard LED of the Node MCU ESP8266, typically used for the status indication. And continue with the web server initialization. Create an ESP8266 web server object to handle the HTTP request on the port of 80. DHT11 sensor setup. Specify the pin connected to the DHT sensor and initialize the DFT object. Let's continue with the LCD initialization. Initialize the LCD display using the liquid crystal I2C library, specifying the I2C address and display the dimension. So let's continue with the gas sensor setup. So here we define the analog pin and connected to the MQ135 gas sensor and initialize the MQ135 object and set up for the concentration threshold for classifying the CO2 concentration into 3 categories: good, moderate, and danger. So here function for the CO2. We imply for a function to classify CO2 concentration to classify the CO2 concentration based on the predefined threshold. Alright, so let's continue with the handle routes. This function is triggered when the node MCU IP address is opened in a web browser. It loads the HTML page and stores in the main page variable and set it to the client. Let's continue with the handle DHT11 temperature function. It reads the temperature value from the DHT11 sensor and send the temperature value to the client as plain text. If the temperature reading is not a number, which is none, it print an error message to the serial monitor. So and continue is clear the LCD display and print the temperature value along with a label. So let's continue with the handle DHT11 humidity. So this reads the humidity value from the DHT11 sensor and send the humidity value to the client as plain text. If the humidity reading is not a number, which is none, it print an error message to the serial monitor, and also prints for the humidity value to the serial monitor to display the humidity value on the LCD display. Alright, so let's continue to the handle gas sensor function. This function reads the value from the gas sensor and process it for the sample CO2 concentration 10 times over 2 seconds to ensure the accuracy. And here is also calculates for the average CO2 value and subtract the CO2 level that we have calibrate it with 70 at the initial of the project to obtain the concentration in parts per million, which is the ppm, the level of the gas concentration. And also here we classify the gas concentration into categories, which good, moderate, or danger, using the classify CO2 concentration function as we have defined at the initial of the project. So continue, it also sends the CO2 concentration and gas quality as plain text to the client and print the CO2 concentration and gas air quality to the serial monitor for the debugging process. And it's clear the LCD display and print the CO2 concentration along with its quality. So here it is delayed for 2 seconds to allow the LCD display to show the data before proceeding. So let's continue with the setup function. Initialize the LCD display and turn on the backlight and clear the display to prepare for the data presentation. Begin the serial communication and baud rates of 115200 for debugging and also monitoring purpose. Continue we initialize for the DHT sensor and wait for 500 milliseconds to ensure the stability. Continue we set the LED pin mode as an output and turn it on to indicate the device activity, and continue to connect to the configure Wi-Fi network by using the provided SSID and password, and is display a connecting message on the LCD while waiting for the Wi-Fi connection. Wait until successfully connected to the Wi-Fi, indicating the assigned IP address on both of the serial monitor and LCD. So continue set up the HTTP server routes for handling the client request related to temperature, humidity, and gas sensor reading. So let's continue and start the HTTP server and wait for 5 seconds to prolong the display of the IP address on the LCD display. Re-initialize the LCD display to ensure the backlight remains on and clear the LCD display. So continue. Finally is the loop function. This handle the client request continuously, allowing the device to respond to the HTTP request from the clients. Execute the server handle client function, which manage to incoming which manages the incoming client requests and routes them to the appropriate handler function. Alright, so let's continue. This script runs on the client-side browser and facilitates with the interaction to the web server hosted on the Node MCU 8266 device. It's utilized with the JavaScript to make asynchronous HTTP requests to the server and dynamically updates the web page content without requiring a full page reload. Let's continue with the function and intervals. Two intervals are set to call the function repeatedly. The first interval executes every 2 seconds and call the function to retrieve the temperature and humidity and also gas sensor data from the server. The second interval is executed every 1 second and updates the current time and date display on the web page. And let's continue with the get temperature data and get humidity data function. It fetches the temperature data and humidity data from the server using an XML HTTP request and update the temperature value and humidity value to display on the web page. Let's continue with the gas data function. It fetches the gas data from the server and using an XML HTTP request, it passes the response to extract the gas value and gas quality, then update the corresponding value and display on the web page. Let's continue with the time lapse function. It updates the current time and date to display on the web page. Client-side communication. This function enables with the real-time data to retrieve from the Node MCU ESP8266 server without needing a refresh the entire web page. The server respond to this request with the requested data in plain text format, which is then passed the display on the web page.